Okay, in this video, I'm going to go through the knapsack problem from the book. The other video I did more detail on calculating upward bound, but I think I got a little off on the algorithm as to when to move forward. So we talked about this during office hours, so this makes sense to go over this one. Okay. So this is the problem 5 from the homework. We have item 1, 2, 3, and 4. We have the weights of 10, 7, 8, and 4. We have those. That's the weight. We have the values of 100, 63, 56, and 12. And then we have our value to weight ratio of 10, 9, 7, and 3. So you have to calculate that by calculating the weight divided by the value. Okay. And our big W here is equal to 16. Okay. So in order to calculate this, we start up here at node 0. That's our initial conditions where W is equal to 0 and V is equal to 0. Okay. And in this case, if we apply the formula here, which is basically taking the current weight of 0, subtracting that from the total weight of 16 and multiplying that by the best value that we have. Okay, so that's going to give us an upper bound here of 160, the 16 times the 10. Okay, for that highest value of what's remaining. Okay, so this algorithm, remember, we have to do a breadth first, okay? So this is our 0th node. So at this point, we have to make the choice here. Okay, this is with 1, and this is without 1, okay? So with 1, we have our W is equal to 10. Okay, that's the weight of 1. Our value is equal to 100. We do the UB formula, we get to 154. Over here, we're still at V is equal to 0, and W, go to the same order. W is equal to 0, V is equal to 0. But now, since we can't use that first item, we have our upper bound of 144, okay? So at this point, we look at those two. We look at the bottommost leaf nodes there, and those are the two that are there, and we determine that this one is the currently superior one, okay? So now we're going to do a breadth first from there, okay? Where we're going to do a with 2, we're going to do a without 2, okay? So if we do a with 2, okay, that gives us here a weight of 17, which is not feasible, okay? With the without 2, okay, we still have the weight of being 10, the value being 100, okay? But our UB has dropped to 142, okay, because we can't use that second value, okay? At this point, we're going to compare the leaf nodes. We're comparing this upper bound and this upper bound. At this point, we see that the one on the right, without 1, is superior. Okay, so we don't keep following this path. We instead move back over to here. Okay, so this one's going to get a with 2 and a without 2. Okay, so the with 2 here is going to get us a W equals 7, a V is equal to 63, and our UB is going to be equal to 126. Okay. So over here, we're still staying with the W equals 0, the V is equal to 0, but our UB is now dropped down to 112. Okay, so now we're comparing this versus this versus this to see where we need to expand. Okay, in this case, it's this one over here that is the biggest. Okay, so now we're going to expand this one. So this one's going to expand with the width 3 and the without 3. Okay. So the with 3 over here gives us of 18, and that's not feasible. Okay. Without the 3, we get a weight of 10, like we had before, a value of 100 as we had before, an upper bound is equal to 118. Okay. So we now compare this one, and this one. Okay. We now see that this one is the one that we want to go with. Okay. And I'm going to move that to the next page so it's clear. So I'm moving this particular item. Okay. So that top, that had the make sure I've got it right. It has a value of 126. Yeah. So it has the weight is equal to 7, and the value is equal to 63. And this is so what it came from was a without 1, but a with 2, where we are from here. Okay. This had our upper bound of 126. Okay. Notice we still have a 118 over on the other side, a UV there. Okay. That's this UV over here. Okay. So from this one, we're now going to go with 3 and without 3. Okay. So with 3, okay, we get the weight being equal to 15, value is equal to 119, and our upper bound is equal to 122. Okay. Without 3, so this is without 1, with 2, without 3, it's going to give us a weight of 7, a value equal to 63, just like the one above it. Okay. And we're going to have the upper bound equal to 90. Okay. So again, looking at the 118 on the left side, the 122 here, and the 90 there, we see that the way to go is off of. Okay. So this one we're going to get, it's not the color I want. This one will be the last one that we can do here. The with 4 and the without 4. Okay. So the with 4 is going to give us a weight of 19, which we can't do. The without 4 is going to give us a weight of 15, a value of 119. Okay. So our upper bound here is equal to 119. Okay. And this is the optimal solution. Okay. So that this is saying with 2 and 3 is our optimal solution. Okay. So again, the point is at every step, we're looking at all of the bottom nodes to see which one has the superior upper bound. Okay. So hopefully that makes a little bit more sense.